Hey, we're looking at Extrema, and we're on a closed interval, and I think I've been calling this absolute extrema. So the first thing I want to do here is I want to find all critical numbers, if there is any. And that means that the first thing we're going to do is take the derivative. And so we have x squared plus 4 over x, and it looks like I'm using the quotient rule here. So that means we're going to take the derivative of x squared. We get 2x times, then we write the denominator, which is x up here, minus the numerator times the derivative of the denominator. And the derivative of x is 1. And it's all over the denominator squared, remember. So now what I do here is just go ahead and simplify this down. This is 2x squared minus x squared. That gives us an x squared. Distributing the negative across, and that gives us a minus 4. And it's all over x squared. So we want to take this, set it equal to 0, and then solve for x. So now back to that definition of what a critical number is, and there were two cases that we wanted to look at, and that was, what number can I plug into this that gives me 0 out, and what number can I plug into this that's undefined. Well, it's not differentiable at that number, and in most cases it's going to be whatever you plug into the denominator. But anyway, okay, so I don't know, let's scroll down. As you can see, first off, I guess before I even get started here, with scrolling down, uh, if I plug 2 in the numerator, I get 2 squared, and that's 4, and 4 minus 4 is 0. So that's going to be one of our critical numbers. And if I plug negative 2 in up here, negative 2 quantity squared, that's also going to give us 4, and 4 minus 4 is 0. So we know that 2 and negative 2 are 0, or critical numbers, I mean. And then if I plug 0 in the denominator, it's undefined. So we know that in our interval, we know that 0, it's not going to be, this is not going to be differentiable at x equals 0. All right, so these are our possible, now I should say possible critical numbers. These are our possible critical numbers. Considering remember, we're inside the interval between 1 and 4. Okay, so we have to stay inside of this interval. Now let's take a look at these critical numbers. Is negative 2 inside this interval? No. Then we would cross negative 2 out. Okay, we would not use it. It's not going to be one of our critical numbers. However, 2 is in this interval, and so is 0 is also in this interval. So 2, we're going to throw it out. So what I'm going to do now here is go ahead and plug in our endpoint. So our left endpoint, which is 1, plug that in, and we get 5 out. And then we're going to plug 4 into our function, and we also get 5 out. Now we're going to be plugging in 2, and we get 4 out. Now I think I might have made a mistake here. 0 is not in this interval. I think maybe I did say 0 is in this interval. And I mean, after looking at this, I'm kind of going, well, what about 0? Well, 0 is actually not in our interval. I may have said it was, but it's not. And so we're throwing 0 out. Okay, so we can't use 0. So the only thing that we can use is 2. Right? So we toss negative 2 out, and we toss 0 out because they must be inside of this interval. It's the only place we're concerned about. It's between 1 and 4. So we plug 2 in, and we 4 out. Now, we have two maximums occurring, and of course a minimum. And I go ahead and labeled here, maximum is occurring at 0.15 on the graph, and also occurring at 4.5. And our minimum is occurring at 2.4. Now let's take a look at the graph. Okay, so we're at the interval between 1 and 4, which looks like 4 got cut off over here. And so 5, which is about here, more about here, 1.5. The minimum is occurring here at 2.4, actually right here at 2.4, and then and see there's